morning and welcome back to Brodeur Land. We are at week 6, day 2. We just wrapped up reflection. We've also talked about translation. Now we're going to get into what we call rotation for the next 2 days. So today we're going to kind of start things off easy with rotation, just kind of get the basics down and do a couple little practice problems, and then we'll bump it up just a little bit tomorrow. So let's talk about what do we need to do for day 2. And so what our learning intention today is can we rotate a point on a graph, either 90 degrees, 180 degrees, 270 degrees, or 360 degrees, in either clockwise or counterclockwise. So let's talk about this. Let's dive in. There's a couple things I need to talk about first before we start doing problems. So first off, and let me grab my notes as well. Right here, you see that we are going to use some, I guess you could say formulas or so to help us along a rotation route. We'll get to that in just a little bit. But what I want to focus on first is clockwise and counterclockwise movements. Now, I'm going to grab my clock right here. Right here, we have a beautiful math clock, but what I want you to look at is this red line right here, this red hand. We call that the second hand. The way the second hand is moving is actually a clockwise movement, and that's where, of course, we get the word clockwise from. And so pretty much a clockwise movement starts at the top and moves around like so. So that's a clockwise movement. Now, of course, counterclockwise is going to be if we went back in time or we went the opposite way of this second hand. So counterclockwise would be going the opposite way, and then of course clockwise would follow the movement of the second hand. So let's talk about how that looks like in math. Okay, now what we're going to do is we're going to rotate about the origin, which means we're going to rotate this point or any of our points today about the origin. Now if you're wondering what exactly does that mean, just like the second hand rotates around the middle of this clock, that's kind of what's happening here. We're just rotating around this middle point. The middle point's not going to move, but our point is going to move around that origin. So that's really what that means. So let's dive in and see how that's going to look. So one thing you got to know is each of these right here, these kind of bigger boxes, are what we call quadrants. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Now you don't necessarily need to remember where quadrant 1, 2, 3, and 4 are. All you need to know is that if I move this point or rotate this point one quadrant into the next quadrant, each that's going to be 90 degrees. So if I move it into this quadrant, that's 90 degrees. If I move it into the next quadrant, that's 90 plus 90, which gives you 180 degrees, which makes sense because that means I would be halfway around. And then if I moved another 90 degrees, that would be 270. And then if I moved another 90, that would give me 360 because I made it all the way around. Now, what that looks like visually is W right here. If I moved it 90 degrees, that would get us down to right here. And I'm just going to call this W prime because that's my new image. Now, this right here was a 90 degree move, 90 degrees clockwise. Now, what we're going to do is we're going to add another 90 degrees and we're going to move it 180 degrees to right here. And that's going to bring us to this point right here. So if we moved it another 90 degrees, that's going to get us to 180 degrees right there. Now, if I wanted to move it another, and sorry, I forgot to label, Brodeur mistake right there. Now I'm going to do 2 primes because it's not the same as this previous image. It's a newer image, so it's our second new image, and I don't want to say that this is the same as that one. And then if I want to move it 270 degrees, it's going to move to right here. and we'll have W, but this time I'll put 3 prime, so it's different from this one and this one. And this would be 270 degrees. Now, of course, if you wanted to go all the way around and get back to where we started, that would get us to 360 degrees right there. And that would be your clockwise movement. And so this is a way to kind of illustrate. The main thing you need to know is to just, each time you move a quadrant or rotate a quadrant, you're adding 90 degrees to that rotation. So let's go counterclockwise really quick, and then we'll get into some of these questions. So counterclockwise is going to be a little bit different. We're going to move the opposite way. So we're going to go around our graph like so, just kind of up and to the left and around. So if I do this one, we need to move our point 90 degrees, but we're going to go into this quadrant first because we're going counterclockwise. And that's going to get me to here first. So this was our first movement, and that was 90 degrees. Next, we're going to get to our next movement, and that's going to bring us down to here. And I'll call this double prime because it's not our first image, it's our second image. And that's going to get us to, 180 degrees right there. And then if I move another time into this one down here, let's see. That would be 2, -3. All right. This would be my W triple prime. All right, this is what we would call our 270 degrees. And then, of course, if I made it all the way back, that would be 360 degrees counterclockwise. So why I did this is to show you how rotations work, so you have a good basic understanding of clockwise movement going around this way and counterclockwise movement going the opposite way. Now, let's dive into these problems and figure out how do we do these problems. Okay, I'm going to start off with this one. This one right here is, I believe, your first question that you need to do. So we'll do this one together, and hopefully that will help you out. What I need to do first is find the point that I need to rotate, and that's A. I'm going to come up here and write A. And I need to find A's coordinates. Now, I'm going to find A's coordinates. That's going to be 1, 3 right there. So I'm going to write 1, 3. Now, what I'm going to do is I'm going to use my nifty little formula sheet above. And remember, you can either pause the video right here to use the formula sheet, or you can find it in the packet. It's up to you. But what we need to do is we need to find on here, it told us we need to rotate 270 degrees clockwise. So I'm going to go on here, 270 degrees clockwise. Notice I don't want counterclockwise. I want the clockwise one. Now, this first part just represents your original point. We have our original point, x, y. Okay? The second one is what we want to change our point to. So it is telling us we need to use -y and x. Now, you might be thinking, okay, how in the world do I use this formula, or how do I change my coordinate into this right here? All you're going to do is, it says we need y now first and x second. Well, my y was 3 and my x was 1. So it just says, well, instead of x being first, we want y first. Instead of y being second, instead of x being first, we want x second. So we put it like that. Now you might be thinking, what is this little negative doing right here? What does that negative mean? This negative means that you want to change the sign of your y. Our y was originally +3. So instead of being +3 now, we are going to make it -3. Now, you are pretty much done. All you need to do to get your final answer is plot -3, 1 onto your graph. So I'm going to go to my graph, go to my origin right here. We're going to go -3 up to 1 right here. Okay, I'm just double checking I graphed it correctly. And then that is going to be where we're going to rotate A. So I'm going to put A right here and then put A prime because it's not my pre-image, it is now my image. And that's it. That's how you would complete the first one right there. Now, let's talk about the next one, rotate 90 degrees counterclockwise. This one is not one of the practice problems, but I wanted to do a counterclockwise and something that was different besides 270. So I tried to do a 91 right here. So we have B prime right here. B prime, what we need to do is we need to find, or sorry, not B prime. It should just be B. That was a Brodeur mistake because that's our pre-image. Our image will have the prime. So we're going to have B. We need to find out what its coordinates are. So that would be 4, -3. So 4, -3. Now it tells us we need to move 90 degrees counterclockwise. So on my list, I'm going to go to 90 degrees, but find the one that says counterclockwise. Go to the end, and it looks like we use -y and x. Now, some people might say, wait a second, Mr. Brodeur, why are we using the same formula we used for 270? Well, the issue is this is 270 clockwise. When you do counterclockwise, it actually will land in the same place. For example, right here, this W went clockwise 270 degrees. But look what happens when we bring W 90 degrees. They land in the same spot. So that's why those formulas happen to be the same. So don't just assume as you look here, all the formulas are different depending on where you're moving. So just go straight to here and find out what you need to use. Now, all we got to do is it looks like we need to put our Y first. So here's my X. Here's my Y. We're going to place my Y first. And then we're going to place our X second. But be careful. Oh, let me put the little parentheses right there. But be careful. This right here says we need to change the sign of the Y. The sign of the Y was originally negative. So in this case, I don't want it to be a -3. I want it to be a +3 right there. So I got 3, 4. Now I'm going to go to my graph. I'm going to go to 3, and then I'm going to go up to 4 right here. And now I'm going to put B prime because B prime represents my new image. So B moved up to B prime right there, and that would be it. So that is how you're going to rotate 2 points. The last question we got to talk about is how we write the rotation rule. So you can actually get 2 possible answers here. You can either do it clockwise or you could do it counterclockwise. I am going to do it one way, and I want you to write the answer the other way. So right here, I'm just going to choose, and let me pick a different color. I'm going to choose red so it shows up a little bit better. I'm going to choose to rotate C to C prime this way. Now, if I rotate this way, that looks like a clockwise movement, okay? And this would be moving just one quadrant. Remember, each time you move one quadrant, that would be 90 degrees. So in this case, I am going to rotate 90 degrees clockwise. And that would be my rotation rule. Now what I want you to do, I gave you how to write it clockwise. I want to see if you can write it counterclockwise. So see if you can try it that way. Again, just a couple last minute reminders. Remember, clockwise goes around the way a second hand moves on a clock. Counterclockwise goes the opposite way. And then use these formulas. These formulas are to make your life so much easier when it comes to rotations. But
Mr. Brodeur, I had one quick question.
Yes, question.
Why did you start at C and rotate it to C prime instead of starting at C prime and rotating to C?
Ooh, that's a good question. So, like we said, remember the primes represent new images. The letters that do not have primes, for instance, right here, the C, that represents our original because originals won't have prime, and that's why I had to change this one to B because Mr. Brodeur made a mistake and accidentally did prime when that was my original. So originals always have no primes, and then new images have the prime. So you always want to go to a no prime to a prime. So good question. All right. So I hope this helped. I hope this answered all of your questions, especially with rotation where it can be a little bit tricky in understanding which way to rotate things. But just let us know. Send us emails, your teacher's emails. We'll be glad to help. But until next time, Brodeur out. Peace.